Hi, welcome back. So we'll continue our discussion around Gen AI and LLM. We'll go a little fast in these videos going forward. So we talked about earlier what is AI, Gen AI, LLM, and how do they work, and we have seen some examples here. Now in this particular case, we will talk about Gen AI versus LLM. Yeah, very simple thing. We have seen LLM is basically one type of Gen AI. So Gen AI is a broader category. It includes LLMs, but also non-language stuff like be it image type or music generator or video type of models also. Yeah. While large language models subcategory are a specialized version of Gen AI only deals with essentially the textual stuff. Yeah. Um, there are multi-model models. Some LLMs like GPT-4o, etc. They handle even multiple types. So there is kind of a gray or a very thin difference between Gen AI and LLM. But then there are a few large language models which even though deal code generation, etc. But there are very specific Gen AI models which are actually fine-tuned extensively for code generation. So that we'll see separately. But essentially, more or less, the large language models in Gen AI are kind of very similar thing. Yeah. Now, why this field is very exciting here, and also why is this little bit of caution required in this particular field? Yeah. First thing, when it comes to the applications, right? Gen AI or LLMs, they can do basically all these monotonous work. For example, if I have a huge amount of patient's information, I want somebody to actually quickly look at the patient details and summarize. That is something which potentially manually, if we do, takes a couple of hours, right? While LLM can do it quite easily because they are very good at language, very good at text analysis, etc. Right? So you can actually build applications, in fact, very effective applications, and those can literally be transforming industries like healthcare. It could be manufacturing. It could be even, for example, software engineering, the code generation, etc. So those kind of applications are very exciting. Okay, that's one thing. Second thing is these LLMs are, in fact, we will actually see these things in our course in future. We can have something called agents created, which can literally use LLMs and bring in a little extra spice on top of LLMs, for example, tools, etc. Right? And these can actually perform a lot of automation stuff. An example I can take, I can actually build a simple LLM based AI automation agent, which can do lots of sales work. It can actually call a potential customer, describe about the project, and query or answer any sort of queries from the customer, and even to an extent, if customer is kind of like very positive, it can actually connect that customer to a human. So here we are essentially talking about doing lot of work which either a person or a human does, takes large amount of effort. Yeah. And these things can be achieved with LLMs on top of additional tools, agents, kind of framework, etc., very easily. Yeah. So that's the positive side of it. Yeah. Now coming to the negative side of it is obviously these can potentially lead to some, at least for the initial phases, can lead to a good amount of job loss. But then people who are essentially losing the jobs may be doing better things, right? Rather than doing the same monotonous work, they can potentially do better things. For example, a junior developer, a software developer, if being replaced with a copilot, AI copilot, maybe that developer can use the copilot to do better thing, like they can build better applications just like a senior developer. Yeah. So this is how there is pros and cons, but the field is very exciting, and very soon a lot of areas will be taken over by AI. And my thinking is human will start doing better things. Otherwise, without AI, they could have stuck with doing these basic things, basically. Yeah. So that's the pros and cons of LLMs. Now, bit of hands-on on LLM, which is quite easy. You guys already, I'm pretty sure you might have used ChatGPT, Grok, Claude type of web interfaces available for popular AI models or Gen AI models. Um, there are some examples which you can try it out if you're completely new to this world. Maybe this looks little exciting, but otherwise, I'm pretty sure you must be using ChatGPT a lot, Grok a lot. So you must be already aware of these stuff. Yeah. If you are not, you can always, I mean, if you go back to our course here on GitHub repo, there are detailed step-by-step instructions on how to do these kind of things. Yeah. So I'm not going through these hands-on things here in detail because these are very basic stuff. Yeah. Now, quickly moving on to the history or timeline. Let me collapse these things quickly. Yeah. Moving on to the history, how all these AI, Gen AI, large language model stuff actually started evolving, right? I'm not going again in detail. This history is very much available everywhere on internet, but just as the context point of view, yeah. So the entire concept of AI potentially might have started very long back, maybe very early 90s, 1920s, etc., where the pattern recognition become reality. So people started identifying patterns, and there is a well-known book on patterns and how these actually work. So which become very fundamental thing for AI or machine learning, right? But then around 1950s is when we can formally say the term AI was coined. It is when Alan Turing's Turing test started talking about machines doing few things which human can do. Yeah. Then 1980s is when the neural network started. These are kind of like layered cells you can imagine, like in human brain. Um, which can perform independent functions, and together of these can actually do a lot of complicated things. Yeah. um, 90s is when the basic language models started coming out, essentially in terms of simple tools to predict words, the next possible word. For example, if I say, hey, I am, then potentially the tool might predict, okay, the next word could be my name. Yeah. So that's because they started figuring out some sort of patterns. Yeah. Then we had this 2006 where the deep learning era started growing, which is a subset of neural networks, a better neural networks to improve AI's ability, right? And this ability gave AI to learn quite a lot of complicated things. Yeah. Now, I'll skip a little bit of this, but very important thing that came in is 2017, where the concept of this transformers came, which kind of revolutionized this Gen AI or LLMs, because it gives an ability for Gen AI or LLMs to actually work with context or understand the context and understand the relation between words and all that stuff. Yeah. That's where LLM started understanding the language context just like human way. Yeah. 18 and around 20s, these BERT, GPT-1, GPT-2, GPT-3 series started coming up. They started making LLMs more mature because of the training data and all that stuff. Yeah. But then it is when post pandemic, I think it is around 2021 2022, where chat gpt 3 and dolly, which is essentially the initial image processing llm, that actually made people's attention, right? People started interacting when OpenAI released their chat gpt interface for their models, llms, right? So that's when all these things started coming up. I think around 2022 onwards, people started interacting more actively with ChatGPT. Yeah, that's where people started realizing the power of LLMs essentially. Yeah, but then 2023, large of other LLMs started emerging. Meta came up with its Llama and Claude was introduced by Anthropic, and Google started talking about Gemini, and that's how things started coming up. So um, that's the history type of thing. So essentially, uh, the timeline point of view, 2025 is something where a lot of new models, very matured models, etc., are being developed. Okay, let's move on to capabilities and limitations of LLM. Yeah, can LLM do everything? If so, what are the limitations that we need to be aware of? Yeah, and these limitations, when I talk about, essentially, these are the ones I'm talking about 2024, 2025 ish type of thing. But then LLMs are fast maturing, yeah, and a lot of things I will explain, which we talk about under the limitation, are almost gone now, and LLMs are much more intelligent, yeah. But anyway, we will try to understand the strength of LLM, yeah. The strength of LLM is obviously this is a large language model, so obviously very powerful language processing models. So they can generate coherent text, very naturally sounding text, very relevant, grammatically correct, and contextually very relevant. So based on the context we are talking about, in our future prompt engineering examples, I will show you, based on the context that is given, they can really generate very nice, professionally tuned, grammatically correct, and naturally sounding, as if like a human has produced that content. Yeah, that's the strength of an LLM. Yeah. Then the summarization, information extraction. These are the general use cases. For example, whenever we do Zoom meeting, we can use Zoom's AI capability or LLM capability to actually record the entire transcription of the meeting, and then it can actually read through that context and regenerate a summary of the meeting, and also it can even do list out all the actions which are discussed in the meeting. Yeah, so these kind of things they can do very well. They can even do brainstorming and creative writing type of thing. We can build an army of agents actually to do a brainstorming of an idea. For example, there are use cases where people can build agents. One agent will be like a software developer, another agent could be an architect, another agent could be a critic, a reviewer type of thing. And we can actually assign a work in such a way and orchestrate the work in such a way that these can talk to each other, in the sense coordinate with each other and generate the content. For example, one LLM or one agent using LLM can generate a code, and another agent using maybe the same LLM or another LLM can actually review the code and provide the review comments. Yeah. So these kind of things they can do very well. Code generation, we talked about it. Then any sort of a dialogue based conversation they can do very well. For example, we can build agents. An example I can take is I can build a real estate agent and provide the relevant context about all the ongoing projects. And this agent can actually have either a web-based or a text-based interaction with end user, or it can even have an ability to call and talk to the person, the customer, and explain about the projects. Yeah, and any sort of queries from customers are basically answered well. Yeah, so that kind of things, any sort of conversations can happen. Yeah, and obviously these are very good at pattern recognition, so they can easily identify segment or sentiment, what we say. For example, Amazon uses a sentiment analyzer for all the reviews. So based on the review given, it can actually put whether it's a negative review or a positive review, those kind of things automatically. Yeah. So these are essentially strengths. So anything related to language, um, because of the vast amount of training that these language models got, they are very good at. Yeah. Now, what are their limitations? Yeah. If you see here, the first one is about hallucination. Yeah, this is essentially something which talks about generating some information, because GenAI is meant for generating the information, but then generating some information which may be factually not correct. Yeah, but then because of the patterns, because of the context, etc., Gen AI might have generated it, but then it is factually not correct. But the way it is represented, the end user might believe that it is actually correct. So that's what we call it as hallucination. Yeah, and I think an year or two before, this was a very predominantly scary problem with Gen AI. Yeah. It used to generate even sometimes simple mathematical calculations go wrong, but then it simply throws the answer in such a way that it is very confident. Yeah. But then over the year, especially after second half of 2024 and 2025, now things are much more matured. Yeah, hallucinations are almost, I can't say zero, but they're very much reduced. And the best part of it is the way you query, what we call it as prompt engineering, you can literally make a very real use case where you can actually suppress all the hallucinations. Yeah, so that's the one of the limitations. So we just need to be a little careful. That's why the concept of prompt engineering is very important here. Yeah. Then the lack of true understanding and reasoning. This is still a bit of limitation. LLMs cannot surpass human intelligence at this stage still. Sometimes we can easily fool an LLM to generate a response which might be not correct with respect to context. So I have given some example in the prompt engineering use cases. We can actually fool an LLM successfully. Yeah? Because it can't really understand our reasoning. If you're able to put the words in such a way, the LLM might end up believing that we're talking about positive. Yeah. Now the knowledge cutoff, most of these LLMs are basically trained to certain extent, right? For example, this was a glaring problem even two years ago when ChatGPT was introduced. It was trained up to certain period of a time, yeah, and then anything that happened afterwards, LLM didn't know, yeah. But now we have ability, we can actually provide an external context. We can further fine tune LLM, or even there is something called RAG, right? Or even using external tools. Yeah, we can make these LLMs go beyond their training data. Yeah, so now this limitation has been successfully eliminated. I can say we have approaches available, workarounds available to make sure LLMs can even do or browse internet and get the latest information. Yeah. Bias from training data. This is again depends on which LLM you are using. There are certain LLMs which were maybe an open source LLM which is not extensively trained may suffer with a bit of bias because underlying training data is human created, and if it is biased, so obviously LLM might end up with some level of bias. Yeah, but now any professional foundation model, if you take, they are kind of very natural, unbiased responses. Yeah. Difficulty with complex mathematical and logical reasoning. Yes, it is still possible to experience, especially if you're a very habituated user of Copilot, which is code generation, LLM. Possible that you might have seen sometimes it struggles. Yeah, it generates a code which may not be doing it things, but it just throws the code in such a confidence that when you actually attempt it, it fails. Yeah, and then you have to keep fine tuning it. I mean, fine tuning its responses by telling where exactly it went wrong and all that stuff. Yeah. So that is one limitation. And then sensitive information, this is much more significant limitation of an LLM because the way they are designed, they keep getting the feedback from user, and this feedback will become a training data for LLM. And it is possible if, for example, there was one use case where Samsung engineers have actually, when dealing with OpenAI model, they end up asking some or end up providing some context which is very proprietary stuff, and then model actually took up that information and become publicly available. Yeah, so that way things can go wrong. The sensitive and private information can become LLM's training data. Yeah. That's why we just need to be very cautious, especially if it is about your personal documents, your financial statements, your health records, your images, in fact, photos, etc. Right? When you're using AI for generating images, you need to be very careful. You're actually giving your selfie for training an LLM, so which may potentially be misused in future. Yeah. So that's another limitation. And finally, about okay, I'll go back. Finally, about the robustness and consistency in the responses. So this is again, LLM can be very creative. LLM can be very straightforward. So you can actually tune it. The way you ask through prompt, you can the responses from LLM can be very creative. So it is possible the same question. If you ask twice to LLM, the responses may be slightly different. Yeah, but then you can tune it. There is something called temperature parameter for LLM, which is available through program world, through which you can do, or else by using very good template, which we'll talk about in the next video, in our prompt engineering video. We will see how actually you can use proper templating techniques to or proper prompting techniques to actually make sure your LLM is not randomly giving you responses. Yeah. So those are the kind of limitations, but most of these have workarounds. Yeah. You can use external tools, you can use appropriate prompts engineering techniques to actually come out of these limitations. Yeah. That's about the limitation part of it. Now, ethical considerations. Obviously, because this whole LLMs are trained on the data which is human created, there are bias. But this is much more mitigated now. For example, if you ask an LLM, a professional LLM, explain the duties of a nurse, yeah, then if you see the response, yeah, it is not talking about any gender. Yeah, it essentially assumes nurse as a role and it talks about that particular role and it doesn't discriminate in any way, saying or referring nurse as a female nurse. Yeah, so that kind of bias is kind of mitigated. Now they are pretty well trained LLMs available. But then this is one ethical consideration. Bigger problem is about transparency, because now LLMs have become so much widely adopted. People started using ChatGPT even for drafting the emails, right? The codes are being generated by LLMs. So there is lack of transparency. What is really generated by AI? What is actually reviewed by human, or what is actually generated by human? So it is very difficult to differentiate. And because of this, things might go wrong. Like sometimes somebody has sent an email which is generated by ChatGPT, and it could be even possible that it's an automated email. Uh, an agent might have actually generated an email sent to customer, yeah, which is not actually sent by any particular person or a company. It is sent by a bot. Now, how do you figure it out whether it is an AI generated email or a human sent email? Yeah. So this kind of transparency is lacking. Yeah. That's where um, we need to be a little careful how to deal with these kind of things. So that's another problem. Yeah. Now, fairness and harm. Again, this is more about bias type of thing. Sometimes possible that because of the training data, the fairness may be a little bit skewed to a particular community of a person, for example. Yeah. But then these things have been mostly taken care now. Yeah. Very problematic area still in LLM world is this security and the privacy. Yeah. Um, I don't know. It's essentially like the data which we are using for are as a context for LLMs, right? How secure they are, and where else it may surface. Yeah, you don't know. You can't control it. Yeah, that's why a larger organizations, especially let's say healthcare organizations or financial organizations, they have a very rigid reviews of these LLMs, and most of the time there is an unwillingness to adopt an LLM for certain thing, because uh, the private data may become public or misutilized. Yeah, and these are all underlying models, right? Nobody controls them, so it is very difficult to control how this data is being actually used. Yeah, so that's another strong ethical considerations when you're using an LLM. Yeah. Now for this, we'll do a bit of hands-on. Again, these are like simulating exercises. Most of the time, you may not get the result that you're expecting because we are trying to simulate an LLM to hallucinate, right? For example, we can use a prompt like list 3 recent scientific discoveries made by Professor Xylophone in the field of quantum astrophysics. This is a made up professor name. Yeah. Now we would expect that the LLM, for example, your ChatGPT interface for OpenAI or Grok or Claude, should figure out that this is a made up name and it should say so, saying that, sorry, it didn't understand who is this professor, rather than um, trying to come out with some recent um, uh, 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 contributions from some unknown scientist or made up the responses. Yeah, so that's the important thing. I mean, if you attempt this, possible that depending upon the maturity of an LLM, you might really see that it has actually looked at scientific discoveries made by a professor in the field of quantum astrophysics, but it ignored this person name. Possible. Yeah. So this is how you can actually uh, make sure that the LLMs are actually not misleading you. Yeah. So this hands-on is about how can we intentionally try to make an LLM give you non-factual information. Yeah. But most of the time, I think because of the maturity of the LLMs now, these things can be taken care automatically. Yeah. Now, other task is about testing some sort of not so complicated, but a mathematical reasoning. Like this is kind of like a puzzle. And when you give this type of puzzle and ask an LLM to explain this and arrive at the answer, um, earlier, maybe an year or 1.5 years ago, LLMs used to struggle and they used to give you half cooked information or most of the time wrong answer. Yeah. But now the same question, if I ask, let's say to the current OpenAI model or Grok model or Anthropic model, they can certainly come up with the very right information. They can clearly explain the steps involved. Yeah. And this is all because of they are constantly being trained and the feedback somebody maybe 1.5 years ago when it has generated wrong information might have given the feedback, so that feedback is taken and they have matured now. Yeah,